This is 4.2 Relations and Functions, Notes Part 2. Number 1, the vertical line test. So vertical line test is a test used to determine whether the relation is a function. Now in class what we've been talking about is if x is the input, y is the output, on any x there can't be two y's. So if we look at number 2, let's say we pick this 2 right here. The vertical line test says that if we draw a vertical line, there should only be one point on that vertical line if it was straight. But it crosses here and it crosses here. So is it a function? No. It should only cross once. On the second one, anywhere I choose to draw a line, it only crosses once. Okay, I can draw this line anywhere. So if it only crosses once on a vertical line, then it is a function. Number 3. I'm just going to go over the beginning of this and then you can complete it. A peach tree grows 2 inches per year. So start from when the tree is a seed. So if it's a seed, the height at the beginning would be 0. At 1 year, if I'm going 2 inches a year, at 1 year it's going to be 2 inches high. 2 years, 4, 6, 8. Now when I'm drawing this, so 1, 2, 3, 4, 5, my height is going by 2, so I'm going to draw that by 2. So 2, 4, 6, 8, 10, and so on. So year 0, it's at height 0. Year 1, it's at 2. Year 2, it's at 4. 3, it's at 6. 4, it's, this is supposed to be 4 here. 4, it's at 8. Now, did it tell us to stop? Did it give us a stopping point? No. So then we would assume that it continues on. So I would have an arrow. Now, is a tree something that's going to jump from 1 year to the next? Is it going to go from 2 to 4 to 6 to 8? Or is it going to happen gradually? It's going to happen gradually. So we can find out where that tree is at a half a year. So this is a continuous graph. So we're going to connect the lines. So you should be able to fill out this section over here by yourself. Now we're going to skip down to number 7. And this problem was supposed to have endpoints. These were filled in dots here. 8 was supposed to have 2 arrows, or just hard to see. And 9, this was an arrow. So on number 7, domain is the x values. So if we're looking at the x values here, this is this horizontal axis. I'm going from 4 to 2, and it's everything in between. So just like we had before with our inequalities, we're going to go from negative 4 to 2. My x's are in between. Since this is filled in, it can be equal to, and since the 2 is filled in, it could also be equal to there. For my range, that's my y values. It goes all the way up to 4 and down to negative 3. So my lowest it can be is negative 3. Remember, we always write this least to greatest, so negative 3. The highest I go is 4. And my y's are in between. So I know I've got my signs here. We have to see if it's equal to or not. Did it touch 4? Yeah, it touched the line there, so it's going to be equal to 4. And did it touch negative 3? This is filled in, so yes. Is this a function? Function means it would pass the vertical line test. Yes. Number 8. Domain, my x values. It's going to continue going to the left and continue going to the right, so I can assume it's going to be all of these numbers on this number line. So I can say all real numbers. or we can draw the R. Range. How high and how low? Well, it's going to keep going further down and further down and further down, so I can't stop it there, and it's going to keep increasing over here. So it's also going to go both ways, so all real numbers. You can draw one or the other. You don't have to draw both of these. And is it a function? So if I draw a vertical line, there's only one crossing point, so yes. Number 9, domain, my x's. Okay, we're going to keep going over here, but over here, this is the furthest I'm going to go is -4. My x's are on this side. So if I have -4 here, x over here, my x's are bigger than -4, but since this is an open circle, it's not equal to. You could also write this the other way, x and -4. It's pointing towards the -4, so all my x's are greater than -4. So it's all of these numbers on the x-axis. My range, I'm going from 4 down. So if I have 4, range is y, all my y's are less than 4, so y's have got to be the smaller number. And this was an open circle, so I'm not going to include the equal to line. And if I switch it, it's going to be pointing towards the y, so all my y's are smaller than 4. Y's are less than 4. Is it a function? Any vertical line I draw, there's only one point. So yes. Okay, let's turn it over to the back. Let's try number 11. If the width of a rectangle is 3 times the length. Okay, here we go. I'm going to call this my length, this my width. Okay, the width is, so that means the width is equal to 3 times the length. Complete the table and graph below. Okay, so if this is 3L, this was just L. Okay, so if L was 1, width would be 3 times 1, which was 3. If L was 2, 3 times 2 would be 6. And we can write this here. Length was L, width was 3L. 3 times 3 is 9. 3 times 4 would be 12. So let's draw that here. 1, 3, 2, 6, 3, 9, and 4, 12. Now, could we break it down and find half of that? Could we find, if length was 1/2, what the width would be? Yes, actually we could. So we want to make that continuous. And then we can continue on if we really wanted to. So we want to draw that arrow at the end. We could find out 5, 6, 7 if we really wanted to. Okay, the rest of this is for homework. So get it finished and bring it back with you tomorrow.